Alright, Chapter 4, Radar System Maintenance. Um, 9 minutes in train course, Navy Electricity Electronic Train Series, Module 18, Radar Principles. Chapter 4, Radar System Maintenance. The non-police for the chapter state will be able to interpret the transmitter frequency spectrum in terms of the frequency distribution power output of the receiver response that accepts the spectrum curve. Describe the methods of measuring the average peak power output of the radar transmitter. Describe the method of measuring receiver sensitivity. Describe the receiver band. Define receiver bandwidth in terms of the receiver response curve of the state with the most common method of measuring the transmitter's receiver tube recovery time. List of the support systems associated with the typical shipboard radar system that describe the basic function that each state the general rules of the prevention and personal exposure of the radio frequency radiation X-ray mentioned. Introduction radar maintenance. The effect of the radar system depends largely upon the care of the attention you give it and improperly adjust the transmitter. For example, they can reduce the accuracy of the perfectly aligned with the receiver. The entire system will become essentially useless with maintenance. Therefore, must encompass the entire system for the basis of operation. Become the complexity of most radar type for the trying to detail the steps of the procedure with specific maintenance. The action of the chapter is impractical. Have the basic of the procedures. Some maintenance action common to most radar systems will be discussed also over the support systems of the radar will be presented. This includes the electrical power, dry air system, the liquid cooling systems, and finally safety precautions inherent with the radars are listed. Transmitter performance chart. The transmitter radar was designed with the operator within a limited band with the frequency's optimum power level. The operation frequency power level outside of the assigned band generally greatly decrease the intensity of the transmitter, make increase the interference with the other radars. Transmitter performance must be monitored closely of both frequency and output power. Transmitter frequency. When the fixed frequency of the tunable type of the radar transmitter frequency should be checked with periodically. The transmitters of the fixed frequency type of the final to be operating outside of the normal operating band with the problem is permitted. Probably the defective part of the defective component must be replaced if the transmitter is tunable, but the transmitters must be given to be tuned to the assigned frequency. Each time a radar transmitter generates the radio frequency pole to produce electromagnetic energy. You should recall you studied the Neets module 12 with the modulation principle of square wave. The modulated transmitter carry the wave with the fundamental square wave frequency to an infinite number of the order odd harmonics and other fundamental square wave frequencies. With the square wave of the modulated transmitter carry both fundamental and harmonic frequency with the square wave heterodyne with the transmitter carrier frequency. Heterodyning is process to produce each of the transmitter radio frequencies on the following frequency. The fundamental carrier frequency, the sum of the difference frequency between the carrier and the fundamental square wave frequency, the sum of the difference frequency of the odd harmonic with the square wave and the carrier frequency. The complete discussion process of use should be the module 12. Actual the radar energy is distributed more or less the symmetrical over the band frequency. The frequency distribution energy, the note that the frequency spectrum of the analyst for the frequency spectrum may be the speaker analyzer present the graphic display the energy versus frequency extensible explanation of the spectrum analyzer the use of the found electronic insulation maintenance book with the test method of the procedure with the Navy 0967 LP 000130. The spectrum analysis properly in the form the interpretive of the spectrum analysis reveal the misadjusting the trouble otherwise the difficulty to locate. They therefore would usually be able to perform the spectrum analysis and understand the result. You may be working while you understand with the frequency, especially with the radio frequency pole. The understand look at the spectrum of the transmitter curve with the response curve of the receiver. The figure 1 the receiver the response curve that has the broader bandwidth with the transmitted spectrum with the interpret the complete with the cover the receiver the response the best frequency within the middle of the bandwidth because the cover the receiver the response with the taper off with the both sides of the center frequency with the until the response passes through the half power points is shown with the curve of the usually response receive the response beyond this one with the too low would be useful with the not consider the note that the spectrum of the transmitter center inside the response curve of the curve of the receiver the yielding maximum efficiency. Half point of the power radio bandwidth of the frequency of the receiver response transmitter spectrum frequency and power. As any frequency would have been modulated, any other frequency would produce the base frequency with the side band frequency. Some of the difference, in other words, the output of the pulse radio will contain more than one frequency output frequency. Spectrum pulse radio transmitter of the design consists of a single frequency that turn on and off of the pulse repetition frequency of the spectrum of the base with the frequency with the modulator with the short rectangular pulse occurring with the pulse rate frequency with the radar with the two the distinct modulating component of the present one component that consists of the pulse rate frequency of the associated with the harmonic with the other components consists of the fundamental odd harmonic frequency that make up the rectangular modulating pulse. Distribution power over the radar frequency spectrum depends on the amount of the modulation pulse of the radar spectrum. The illustrated figure 4 to the vertical line with the representative of the modulation frequency produced by the pulse rate frequency they associate with the harmonic loop representations of the modulation frequency modulation fundamental principle of the pulse frequency. The associated harmonic amplitude of the main loop falls to zero on each side of the carrier. The side lobes are produced with the outer harmonic, the fundamental pulse frequency, 0 point with the produced with the even harmonic, the fundamental pulse frequency, an ideal spectrum in each of the frequency above the carrier with the counterpart with another frequency below the carrier. These frequencies are equally spaced, they have the equal power, therefore patterns symmetrical above the carrier. The main lobe of the core contains the major portion of the transmitted radio frequency energy. Maximum of the pulse made carrier. Radar transmitter good condition should produce the spectrum curve the similar with the curve shown in view A and B with the figure 4. 3 good curve of the two have the symmetrical contain the deep, well-defined minimum points, minima, and both sides of the main peak. So the good spectrum, fair spectrum, poor spectrum, bad spectrum. A curve with a well-defined minimum of this curve that is shown to you see with the indicator of the transmitter output of the being frequency modulated during the pulse. The condition may occur with the pulse without sufficient side with the flat peak, this will apply with the transmitter. This may also with the transmitter to the unstable, operable with the proper voltage current in the magnetic field. Extremely irregular spectrum, they discover the VUD with the indication of the severe frequency of the modulation condition will usually couple the trouble to receive the automatic frequency control, as well as general level of the signal strength with the alpha and improve with the faulty spectrum and adjusting the transmission lines. Job with the replacing the transmitter tube. The spectrum have the two large peaks are quite apart with the indicator of the transmitter tube with the double moding, the shifting of the one with the frequency. This could cover the standing wave of the transmission line with a faulty transmitter tube. Standing waves can be maybe with the faulty line connection of the bad antenna rotating joint of the obstruction in the line. The standing wave that described in Neets module 10 with the introduction of wave propagation transmission antennas. In this case, the good and fair spectrum with the sharply defined minimum points of both sides of the main lobe distance between the 2 points with the proportional duration of the transmitted pole of the device. Most commonly, you would check with the frequency spectrum of the radar transmitter of the spectrum analyzer. Your frequency measuring device. The device you determine the basic frequency of the radar transmitter, the electronic frequency counter with the wave meter with the echo back with one over these devices that include with the radar test with the design with the specific system type of the radar test type with the quite often consider the several type of the test equipment. The combination of the test equipment enable the both of the transmitter receive the performance check to be carried out with one test instrument. Electronic frequency counter with the frequency meter of the wave meter with the discover the each module 916 introduction test equipment. They go back with the discover the next section and speaks like equipment and procedures required to measure frequency with any of the radar system are found with the associated system technical manual related to preventive maintenance checks, preventive maintenance services documents. The echo box. The echo box is important with the interest instrument indicated for the overall radar system performance. Echo box with the those results reflect with the combined relative to the effectiveness of the transmitter energy of the receiver energy. The echo box resonance chamber with the basically consider the resonant cavity shown in figure view A with figure 4 with adjusting figures on frequency cavity bearing with the side of the cavity large cavity with lower frequency calibrated tuning mechanism to control the position of the plunger. Therefore, the side of the cavity the tuning of the mechanism to adjust the maximum meter of the deflection and cavity. The echo box doing with the side of the transmitter. The frequency of the tuning mechanism and also indicated on the dial. Figure 45 the view A with the both of the course transmitted frequency with a numerical reading. The reading permit for the technician to determine the transmitted frequency with a greater accuracy referring to the calibration curve on the chart 45 UB. For the tuning mechanism, input loop with the direction coupler with the resonant cavity plunger output with the loop with the 2 meter show the crystal rectifier with output with the capacitor radio frequency RFC circuit with the meter the antenna of the directional coupler echo box with the receiver the magnetron transmitter receiver box. Records frequency inner dial, middle dial frequencies, and then your megahertz per inner dial revolution middle scale division. Energy is a coupled with the cavity radar mean with the radio frequency cable to connect with the input loop. The energy is coupled with the cavity rectifier mean with the output loop. They can vary the amount of the coupled between the echo back with the crystal rectifier changing the position of the output loop of the schematic diagram. Output circle with the figure 4 view B with the energy picked up with the loop of the rectifier filter with the ply the meter of the method of tank with the echo back with the radar system shown view 4 view C. The ring time measure. Some of the energy generated by the radar transmitter the pick up of the echo back with the meaning for the directional couple of the energy couple the oscillation known as the ring of the echo back with the permit the sum of the time after the end of the radar pulse much of the as in a fashion of an echo perceived with the large room after a loud noise the echo to dive down with the part of the feedback of the radar receiving the system that gamma the meaning the directional couple of the ring causing saturating signal to appear with the radar indicate the figure 4 6 the longer the ring extend the better the performance of the radar. The ringing time, the engine for the ringing time, and the planned position indicator background noise and snow. The length of the time the echo box should be ring with a particular condition for the test is considered expected ring time. You determine whether or not the radar is performing well with the comparing and expect with the ring time of the observe the ring time and expect with the good radar depend on the particular type of the radar with being tested on the way with the echo box until the weather, the directional couple of the pickup of the dial pole on the length of the type of the cable on the individual ring and build with the particular echo box with the frequency of the radar with the temperature of the echo box with the time of the test. Corrections I know made with all the factors according to the procedures given the technical manual echo box you use. You may use the echo box without correcting the detect of the chain with the performance of the radar. You may simply along with the compare of the ring time of the day you should recognize the readings not permit the comparison of the particular radar with the performance. However, you can use the rating with the tell of whether or not the performance is deteriorating. Pick up the ring measurement that's not available. Signal feature of the echo box. Then once you measure the proper ring time measure, they're made with the A scope. The plan position indicate the measuring ring type should be made with the ego box ring, not some fixed target echo of the block or block echo of the being monitored. Be determine the condition they adjusting the radar gain control again, noting the ring time and the varies of the scope of the echo box ring with change the duration. Fix the target with the echo with the however not will change the duration. To the same of the best result. You should repeat every ring time of the measure with the lights 4 times, but then after the readings, you should take special care to ensure that all the readings are accurate. The 2 more technicians of the same eco box, they should practice together until the ring time measurements agree. Alright, your transmitter power measurement. Because of the higher power of the radio frequency, the producer of the radio transmitter special G for the U that measure the output of the higher peak of the band is needed for the radio transmitter to produce the stronger echo of the longer range. The low average power of the desired power because of the enable the transmitter. But the component that could be compact, more reliable to remain the cooler in duration. But because of the consideration low possible duty cycle of the power pulse width and power pulse, the pulse rate frequency must be with the best operation. The relation of the peak of the power, the average power of the duty cycle was described in Chapter 1. Peak power within radar of the primarily designed with consideration depends on the relation between the average power pulse within pulse repetition time. You take the power measure of the radar transmitter with the sampling with the hour power with the one with the sampling method. Pick up the home with the front of the antenna. Airloft, the weather condition of the horn plate is extremely critical, but it also affects the accuracy of the sample. The most accurate, convenient method can be used. In this method, sample the output through the directional sampling coupler located at the point of the transmitter where the power rig is designed with the power amplifier transmitter. Usually have the same couplers after each of the stages of amplification. Some of the radars have the built-in power measuring equipment. Other requires you with the general purpose of the equipment. Special tests set with the in-keep the measuring instrument that the most often referred to as the 1 milliwatt reading with the take of the decibel. The discussing the decimal measurement is presented in the Neets module level. The microwave pencil to take with the power measurement must also with the power loss of the must add the directional coupler actuation pack the loss of the connection cable the power meter reading of the sum of the total power reading. For example, the directional coupler with the actuation picture of 20 decibel, the connection cable will allow for the 8 decibel the reading of the 10 with the power meter the 21 decibel. Therefore, the transmitter output with the power of the 49 decibel, 21 plus 20 with the plus 8 with the power reading of the 4 decibel the obtained with the above the receive the normal cover will allow for the provide useful information. Although the conversion can be accomplished mathematically, procedure relatively complex and seldom necessary for the most of the radar system. Conversion chart show the one shown the force of the test to the transmitter of the test command. As you can see, with the chart with the 49 decibels is easily converted to 80 watts average power. Power output of the radar system in the decibels, and the power output of the radar system in the watts. You convert the average power with the peak of the power with the dividing average power with the duty cycle of the radar is above the example of the duty cycle of 1,000. Then peak of the power can be calculated with the following. Peak power is the average of the power duty cycle of the 80 watts over the 1,000th or 80,000 watt of the kilowatts, and the radar system that has the chart available to cover the average power of the peak power. Receive performance check. The performance of the radar receiver determine the several factors must have the established design and engineering equipment. The paragraph and the following factors concerned with the main consider the important factors of the one receiver sensitivity include the noise factor determination minimum discernible signal with the measurement of the 2 transmitter receiver the recovery time receiver the bandwidth. Many radar systems contain circuit with several special functions. 3 special circuit that contains automatic gain control, sensitive time control, the fast time constant. The circuit can be found with a combination along with it depending on the purpose of the radar. While the test method the procedure to be used there are the special functions should not be used. The automatic frequency control circuits are included with the radar that may be permitted to operate during the receiver test. That's a good way with the check of the automatic frequency control with the circuit operation is complete with the test specified with the manual tuning and switch to the automatic frequency control if the automatic frequency control circuit is operating and normal. The test indication should not differ. Receiver sensitivity. Insufficient detection through range of the radar system can be used to decrease the sensitivity of the radar. Receiver the condition result of the manually with a great number of the adjustment components associated with the receiver. The receiver sensitivity the same function of the brain. This is done with the discrete the transmitter power with, for example, the decibel 6 decibel allow for the receiver sensitive short. The fact that the range radar short as much as the 6 decibel allow for the transmitter power. So if the drop of the transmitter power is evidently easy to detect. On the other hand, 6 decibel allow for the receiver sensitivity, which is easily resolved with this slight adjustment, the misadjustment of the receiver, difficult to detect with the accurate measure of the made. Figure 4A, the comparison of the radar system performance varies maximum range, system performance of the loss of decibels included both transmitter receiver the loss of the shooting out low and the loss of the 5 decibels both receiver the transmitter total 10 decibel only 55% of the maximum range system is realized. Show the percent of the maximum range over the decibels down with the optimum maintenance performance. The sensitivity of the radar receiver of the measure with the ability to pick up the weak signal of the greater with the sensitivity receive the better with the receiver the pick up the weak signal for the receiver the measure for the power level the minimum discernible signal defined with the way weakest signal to produce the visible receiver output on the scope of the value of the determine whether the receiver output north end of the output obscure the weak signal with a minimal discernible signal of the measurement that depends on the receiver the noise level of measuring either the minimal discernible signal or the noise level of the noise figure will indicate the receiver sensitivity. Many radar systems have built-in receiver sensitivity circuits to indicate the sensitivity of the receiver. The technician, the operator, the measure of the discernible signal with must measure the power of the test pole with the level was just sufficient to produce the visible receiver output of the radar with the receiver of the discernible signal level specified the manual for the manual of the noise figure. There should be also correct. Therefore, the measurement of the discernible signal is a satisfactory substitute noise figure determination that's left complicated. The bolts receiver the sensitivity reading of the taken periodically comparison part because the indication profile of them might be each of the maintenance instruct with the radar usually specify the correct pulse value of the radar sensitivity says in most cases is the same the transmitter pulse length. Before any measurement of the receiver the sensitivity can be made of the receiver the most accurately be tuned the transmitter frequency and receiver the transmitter frequency both likely cover the improperly adjusted malfunction local oscillator transmitter frequency drift. Some problems can cover by heating and aging component of the local oscillator tune the process they drift according to the type of the radar. Therefore you should follow the tunings perceived the system manual. The two basic methods of the measure radar receiver the sensibility. One with the pulse method, pulse is measured amplitude width of the couple of the receiver. The second method is with the frequency modulation generated to vary the single generated output frequency. The couple of the receiver the bandwidth the later method use ensure the test signal with the band path of the receiver. The sensitivity of the receiver is equal to the sum of the reading of the signal generated with the actuation of the connection cable directional coupling of receiving sensitivity expressed with the negative decimal. For example, the 90 negative decibels expressed the sensitivity of the receiver to 90 decibels less than 1 milliwatt reference level. The time the receiver the sensitivity reading of the mounted radar should be in the vicinity of the 105 decibels. Our receiver bandwidth tab. The receiver bandwidth is defined with the frequency spread between the half point of the receiver the response over the receiver bandwidth is specified with each of the radar, but the variation that are often tolerated. Either the bandwidth is shape of the receiver, the response over with intolerance to detailed circuit with the current circuit component, the bandwidth necessary for the considerable chain with the value circuit component is required to alter the response. You should check the receiver response if any with extensive repair with the intermediate frequency amplifier figure 4 show the typical response curve of the radar. Receiver the half power points with a shown figure 3 decibels below the maximum response. Since the curve is and determine the voltage of these points off to the representative 70.7% of the voltage points shown in the figure. Figure 4 9 for the typical response curve of the receiver the bandwidth half point the voltage output of 3 decibels and 77.7. The transistor resistor recovery time. The time recovered the transistor transmit resistor recovered the time to take up the transistor resistor switch tube. After the transmitter pole usually defined with the time recovered the receiver the return with the 6 decibel normal after each of the transmitter poles will have with the manufacturer the time of the required sensitivity to return the 3 decibels with normal sensitivity recover the time of the fact of the limit of the minimum range of the radar of the radar receiver that unable to receive the transmitter receiver switch is the DMF of the various radar of the recovery time of the we could differ with the left of the 1 microsecond with the 20 microseconds. Primary function of the transistor receiver to switch for the protect with the sensitivity crystal detect with the powerful transmitter pole the evidence for the best for the transmitter receiver switch to level the stress when the power of the leak through but with the switch is functional properly with the leak power so small that it does not dim with the crystal. However, the use of the life of the transistor transit resistor tube is limited because of the amount of the leak to receiver to increase the use to ensure the efficiency and performance of some of the technician must possibly replace the transistor resistor tube after determining the number of hours practical measure for the transistor resistor recovery with a frequent interval to make the graph chart of the immediately close with any of the change of the performance figure 4 10 of the recovery time of the correlated with the leak power. Note at the end of the useful life of the transistor resistor tube indicate the increase of the recovery time. Show the leakage power of the recovery time at the end of the useful life of the recovery time life an hour. The method of checking the condition of the transistor resistor tube that reliable recover the recovery time increase before the leakage power with the excessive practical transistor resistor tube the play for the unity sharp with the increase of the recovery time that becomes the parent. Ambient temperatures also have an effect with the recovery time of the cold over the transistor resistor transit resistor tube with the greater the recovery time of the same that's recover the under widely varying temperature condition effects might be considered. One method is testing the transit resistor tube is mentioned for the keep the lab with current keep the transistor resistor tube the partially that makes the firing more instantaneously less helps protect. Whereas the crystal will keep the lab with current normally 100 microamp at the fall of the at the end of the transistor resistor tube. Life with approaches you can also measure the keep the voltage between the plate of the transistor resistor tube and the ground with the voltage over the known the correct output of the record of the voltage of the U of the reference feature. Check the output check that are not reliable with recovery testing time. Specific perceive the measure for the transistor resistor leak of the recovery time can be found in the equipment and technical manual. Standing wave measurements. You may want to refer to the Neets mental intent of the introduction wave propagation transmission line of the intent of the review of the standing wave before going further. The measurement of the standing wave, the indicator of the approximate operation frequently present with the defect of the transmission line. Check the condition of the antenna of the standing wave, the presence of the transmission line wave guide that indicate the impedance of the mismatch between the transmitter and the receiver and its of the with the condition of the accurate of the transformer of the energy between these units becomes inefficient. The reflecting of the energy low of the end of the transmission line result of the wave of the travel the down with the generator and the wave of the barrier continuously leaving the phase of the merge state when the wave of the incident wave varies in favor of the certain of the point of the half wave of the wavelength apart two wavelengths exactly in favor of the resultant voltage maximum a quarter of point for the quarter wavelength for the maximum two wave of the opposition voltage. Note the null points are produced with the ratio of the maximum minimum voltage is touch points called the voltage standing wave ratio of the maximum minimum current along with the transmission line is the same as the voltage standing wave ratio. The high of certain voltage standing wave ratio is 1.5 to 1 or higher. Indicate the characteristic impedance of the transmission line. If there is greatly with the terminating impedance, the low voltage standing wave ratio, the 1 to 1 is the best indicator of the good impedance between the transmission line and the character of the impedance of the testing of the terminating impedance. The radar application low voltage standing wave ratio is out of the following reasons for the reflection of the transmission line without the improper transmission operation call that the result of faulty pulsing. The effect of the pulse must be pronounced with the line of the long compared with the wavelength of the transmission after the arc over the main occur with the maximum voltage point. 3. The hotspots can occur with the transmission line called the mechanical breakdown since the transmission line with the radar equipment the normal coaxial cable the waveguide slotted with the line's directional coupler may be used the same wave measurements. Hard support system. You think the radar equipment, the complex electronic circuitry or the sophisticated equipment that you may forget the entire radar relies on the other system. The other system referred to the source is not normally through the part of the radar. The support systems are electrical power drive over the liquid cooling system. With the support for the system, radars cannot function. Therefore, you must be aware of the subsystem to understand the relationship of the equipment. Electrical power. Like now, the typical ship power distribution of the power system of the ship of the aircraft will probably similarly in many ways. You probably discover the overall power distribution and the air is closely related to the radar equipment. The power distribution AC power distribution system is a naval vessel of 440 volts, 60 Hz, 3-phase, 3-wire underground system. The AC power distribution system consists of the power source equipment that distributed power with equipment that use over the power distribution chart shown here 411. Or the power source can have the ship the turbine generator, emergency level generator, diesel generator, the power that normally distributed with the ship the distribution switchboard with the power panel with some of the large ship or load center with the not showing the function of remote switchboards. Power the equipment that requires electrical power, the operation light motor, the direction of the power drive of the radar equipment. Where with the direction, the equipment that computer with the manufacturer server the generator, the emergency generator, the distribution switch is in the responsibility of the ship engineer, machinist mates, electronics mates, engine man, and engine emergency power. If the power of the ship, the distribution system interrupt the emergency powers emergency power distribution system is activated. The emergency system supplies immediate automatic source of the electrical power to select the load for the vital and the safety and defense of the ship. The system includes one or more of the emergency diesel generator switchboard with the emergency generator that starts automatically with the sensor to detect with the loss of the normal power of the bus. Transfer equipment is bus transfer equipment is installed with the switchboard with the load center of the power panel on the load that is both normal and alternating emergency feeder figure or level the normal alternating source of the ship service power is can be selected with the emergency power with the emergency distribution system can be used with the emergency feeder is also provided. Automatic bus transfer of the equipment is used to provide power with vital loads with the non-vital loads for the chemical power fed by the manual bus transfer equipment. For example, the interior communication switchboard is fed by the automatic bus transfer, which the Alta input from the emergency switchboard. The switch radar might be fed back to the manual bus transfer. Miscellaneous power. Many other apply voltage of the radar system subsystem utilized with the reference voltage of specific function while missing the power input of your equipment that work backwards load with the shores usually with the power panel with the bus transfer unit with the equipment located nearby, possibly in the same space that is in a passageway. Keep in mind the techniques have corrected many unsuspected casualties merely by restoring a minor power input with a significant signal reference sometimes after troubleshooting. Your dry air system. Some of the radar depends on the input of the dry air with the power operation. Radar dry air is normally supplied by the ship at the time of the dry air system. Produces the high pressure for the air low pressure for the dry air distribution of the user of the equipment if such for the fire control radar. Electronic dry air branch. The electronic dry air branch is fed by the vital surface of the LP with the air point through the type 2 descent and type 3 combination of the refrigerant descent of the dehydrated shown figure 412. The purpose of the electronic dry air branch is to provide several electronic equipment with the air dry enough for the proper operation of the microwave components of the waveguide the cavity of the power amplifiers required dry air to prevent arcing and internal growth. Electronic dry air branches must satisfy the dry air requirements of electronic user equipment. Dry air less than the required specification will degrade the equipment. The performance also incur the major response to the overhaul to replace extensive electronic components. Um, Air control component control panel. The dry air distribution system deliver the dry air to each of the control panel. You the equipment. The air control panel will use the control to regulate the dry air pressure required with the electronic use of the equipment. Air control panel provides me with the monitoring the dry air supply with the UV equipment. The type of the control will be the dry air depending on the outlet pressure of the flow of the required. The dew point of the relay of the moisture content flow of the LP on the dry air amount of the air control panel. The dry air pressure the amount of the input of the control panel. The input of the flow medium with the accurately calibrated with the certain precision. The output of the control panel with the filtered into so of the trap particle with the effect of the proper pressure of the regulation of the metering valve bypass the pressure relief valve and the producer of the cowls in case malfunction of the metering valve bypass meters manual control of the air pressure for the user equipment. Electronic equipment dehydrators. Our dehydrator compressor dehydrator supply with the other parts of the various radar, many of the where the provided proper prior installation properly configured with the central dry air system. The dehydrators are intended for the emergency of the vent failure with the central dry air system. Typical configuration figure 4 to routine outlet of the air with the local dehydrator connected between the air control panel outlet of the use of the equipment, the radar, and three-way valve. Local dehydrator depends on the ship of the LP of the air of the inlet supply with local air compressor with the dehydrator can independently shift the air supply. Some of the unit electronic they have the local dehydrator unit air interlock with the dehydrator unit outlet of the air the pressure for the sub the air interlocking but preventing the equipment from everything going full operative condition. Central dry air system with the pressure and interlocking bypass. Some of the radar provide the tank of the nitrogen emergency source that can be connected with the place of the dry air with a special safety precaution must be taken on the handle compressed air gas because the possible explosion. Nitrogen does not support life when relief the confined space can cause exfoliation, cooling system. Radar equipment, particularly high power transmitter, generally large amount of the heat must be dissipated to prevent damage for the equipment to prevent aerotic circuit to operate for the most. Radar equipment must have the high capacity air conditioning system to control the room temperature. However, the equipment happens to have additional cooling controlling internal temperature in the cave of the transmitter. Other high voltage circuit individual components may require cooling. Cabinets generally relatively small amount of heat maybe require only small fan blow over the maintain constant air circulation. Some of the air circulated through the liquid cool heating exchange located inside of the cabinet. Most of the low power amplifiers tubes are air cooled. Most of the high power tube of them are such as the electron and the cross-failed amplifier magnetrons are liquid cooled. Means for the power heat of the power liquid amplifier package for the high voltage power supply. Part of the power produced with the power amplifier transmit the perform of the radio for the energy remain with the power eventually can be reverts to heat with the and cooling with the heat required to receive the heat. Radar use the blower of the cooling while using the airflow sensing switch with the blower fail with the switch open and remove the power app appropriate the power supply with the radars employed liquidity cooling normally distributed liquidity of a large number of the separate path the pick up of the flow required the inquest this limit each of the various path of the low interlock with one of the liquid cooling path becomes restricted low interlocking switch they will open and remove the power from the radar. Liquid cooling system includes the pressure gas switch, the temperature gauge, the evaporator over temperature switches. Many systems have pressure flow regulators. Some of the system audio with the visual alarm the engine drive because of the damage actually occurs. In some cases, they allow the problem to be corrected without turning off the equipment. In Figure 415, illustrate the typical transmitting cooling system shown on the penny for the regular devices. Distilled water is one of the most best meaning with the cooling with high power component of the main case. The only medium that may be used for distilled water and cooling system operating satisfactory temperature, quality, purity, flow with the pressure for the water to be controlled. The control is provided various valves, regulators, sensitive meters, instruments measure the necessary and the character of the provided required regulation. Liquid cooling system consists of seawater or chilled fresh water. Section cooling is distilled with the water and circulating with electronic with the main component of the cooling system or pipe with the valves, regulators, heat exchange with the drain, circulating pipe with the extension tank with the gauge of the demineralized. Other special components, there's some type of necessary to monitor cooling water electronic equipment. Typical liquid cooling system is composed of the primary loop and the secondary loop. The primary loop provide the initial source of the cooling water, the secondary loop to transfer the heat load of the electronic equipment, the primary loop of the source of the cooling water from the primary loop of the either sweet water for the seawater supply with the chilled water from the air of the cooling conditioning plant. The cooling water used the secondary loop is distilled water. Ultra pure systems are maintained with demineralized double still distilled water obtained with the Navy supply system. Additional information about liquid cooling system can be found in the basic liquid cooling system in the shipboard electronic equipment technician handbook Navy C 0948 LP 1228010. Alright, safety. Many safety hazards involve the operating the maintenance of the high power radar that have the result of low radiation, radio frequency radiation, X-ray emission, the necessity of working aloft will generate extremely high voltage. Navy professional very safety encounters of the result of the number of the accident that occur with the very job is small. Most of the safety precautions applicable to the radar are public with radar technical manual. Most of the safety regulation, including the technical manual, as a result of the actual experiment of the Air Force, should give them a careful thought to strict observance. Radio frequency radius and have the radio peak of the power of the reach of the million watts or more of the radio frequency radiation hazard exhibit the vicinity of the radio transmission attempt of the hazard presented not only from the attempt of both on the sometimes even behind it because of the slip over the reflection. Some of the frequencies exposure, so because the level of radiation will the position sensation of the pain with the discomfort to warn you any of the injury. Suspectly any of the injury, you should see the ship doctor or corpsman. Be sure to acquaint yourself with the actual radiation hazard zone of the radars on the ship. Personnel should observe the following precautions to ensure the personnel are not exposed to harmful radiation. Radio frequency radiation. Visual inspection of the feed horns opening of the wave guide for any other opening of the benefit of the radio frequency energy should not be made unless the equipment is properly secured and tagged for the purposes of being made. This personnel should observe the radio frequency radiation hazard signal posted in the operation area. All personnel should observe the radio frequency radiation warning sign with figure 417. The poem of the existing of the radio frequency radiation hazard specific location area may count with the other type of the radio frequency hazard sign depending on the situation. Should the radiation hazard warning signs available and posted. Should the radar attempt to normally rotate, then rotate continuously while radiating on the train. No safe bearing. Ensure those instruments do not normally rotate and are pointed away from the inhabited area. Shift appears likely while radiating. Dummy loads should be employed by applicable transmitting equipment during testing and the checkout. Alright, warning sign, X-ray emissions. X-rays may produce high voltage electronic equipment and radar of the X-ray can penetrate the hematitific damage of the temporary permanent nature of the unless the dose is extremely high with no ill effects will be noticeable the day of the weeks or even the weeks later after the exposure. So the X-rays are usually confined with a magnetron glycerin with the cathode ray tube. The personnel should not link with any of the top of the equipment. The equipment the cover to have then remove the glycerin magnetron, receive the rectifier of the other type that will employ the excitation of 18,000 volts with the more than emit the X-ray over the few feet thus unshield the personnel standing working close with them. The tubes will be in danger. When performing maintenance of the X-ray emitting device, you should take the following precautions. Observe all the warning sign figure 418 of the equipment, always precautions, and the equipment technical manuals. Alright, unless called for the technical manual, do not bypass the interlock with the permanent surface of the operating equipment. The X-ray shield is removed. Be sure to replace all protective X-ray shield when servicing is complete. And Chapter 4 summary.